So here one sample space is given, which is containing some matrices of order 2 cross 2 and elements are 0, 1 and 2. A is a set which is containing that matrices which are belonging to the same sample space where M is invertible. So if M is any invertible matrix, it simply means that value of M should not be 0. So that of M should be not equal to 0. Then they are asking to find the probability of A. So basically we have to find the probability of A where A is an event where that of M is non-zero, right? So if we write total such matrices with entries 0, 1, 2, so that we can say that let's say A, B, C, D. So we can choose A value either 0, 1, 2. So we have three choices for A. Similarly, we have three choices for B. Same, we have three choices for C and for D also three choices. So total such matrices are 3 into 3 into 3 into 3. So that is 3 power 4. So 81. Now we have to find those matrices their det is not equal to 0. So if we calculate first that all those matrices with their det value 0, so from total we can minus all those matrices whose det values are 0 with the det 0 and divided by total, so that is our required probability, right? So if we count that det of M equal to 0, so in that case we are getting AD minus BC equal to 0. So suppose if we are using values for ABCD, ABCD belongs to 1 and 2 only. So basically we are not using 0. So we are first want to count such cases where ABCD can take value 1 and 2 only, right? So we can write AD minus BC equal to 0. So let's say if A value is 2, D value is let's say 1 minus, so 2 into 1 minus 2 into 1, that value will be 0. Now 2 into 1 minus 1 into 2, again 0. Now this is 1 into 2 minus 1 into 2, that is also 0. And 1 into 2 minus 2 into 1, that is also 0. And if we take all values equal, like A equal to B equal to C equal to D, and where we are using 1 and 2 only, so we can write 2 into 2, we cannot 2 into 2, so that is 4 minus 4, so 2 into 2, or 1 into 1 minus 1 into 1. So now in this case, when we are not using 0, such matrices we will be getting. So there are 6 such matrices, right? Now if we use 0, let's say 4 times, so 4 zeros if we are using, so that will be only we can write that determinant as 0 0 0 0. So there is such one case, right? Now if we are using 3 zeros, so we can choose any 3 places out of 4, and this place we can fill with 1 or 2. So this place we can fill with 2 ways, and 4C3 ways we can choose where we have to keep these zeros multiplied by 2. So 4 into 2, that is 8 such matrices we can make. Now if we are using 2 zeros, so if we are using 2 zeros, so in this case we have to be little careful that AD minus BC we need 0. Suppose if we are taking A and B 0, and other two places we can fill with two ways. So either we can take A and B 0, or we can take A and C 0. So this is A 0, this is 0, and these two places we can fill with two ways, right? These two places also we can fill in, either one or two we can put. Or so these are when we are taking a equal to b equal to 0, right? In this case we are putting a equal to c equal to 0, and other two places we are filling by two ways. So if we are taking b and d 0, in that case we can put like this, and these two places we can fill in two ways. Or d and c we can take 0. So this is a. In this case we took b equal to d equal to 0. So in this case we are taking d and c 0. So a, b, c, d. So these two places we can fill in two ways. Any other possibility is not there in this case. Suppose if you wish to write 0 0 here, so these two, because we are using two zeros, right? So these two places, that value will not be 0. Here we are counting for all those matrices whose that value is 0. So in this case, this type of matrices we are getting 4, or 4, or this also 4, and this also 4. So total we are getting 16 such matrices. So in this case we are getting 16 such matrices. So the total matrices, and 1 0 if we wish to use, that is of that will always give that value non-zero. So 1 0 we cannot use. So now that total matrices we have 81, and minus total minus number of matrices with their that value 0. So number of such matrices we are getting 16 plus 8, that is 24, 6, 30 plus 1. So 31 such matrices we are getting divided by total. So that is our required probability. So the total 81 matrices minus 31 divided by 81. So we are getting 50 by 81. That is our required probability. So which is option fourth we are getting. This is the correct choice. So I hope this is clear.